Before we investigate calculations with solutions, we're going to need to take a look at the definitions. The first one is the solute. Solute is a substance that is dissolved in the solution. So if we're looking at a salt water solution, then the solute is the salt. The solvent is the water. It is the substance in which another substance is dissolved, forming a solution. Concentration is the number of moles of solute per unit volume of solution. And the way that we normally do that is in moles per cubic decimeter. A standard solution, you might think that it's got to do with 1 mole per cubic decimeter or something. It's actually just a known concentration. If we know what the concentration is, it is standardized at that known concentration. So, to work out concentration, we're going to say number of moles divided by volume. We abbreviate concentration with a small c, number of moles with an n, volume with a capital V, and what do we measure it in? Number of moles is in moles, volume is in decimeters cubed, and the unit of concentration generally that we use is mole per cubic decimeter. How do we make a standard solution? We get this thing called a volumetric flask, and it will always have an exact little line on it somewhere, and it's called the graduation mark, and you will put a certain amount of substance in there, an exact mass, and then you will make it up to a particular volume. Standard solutions are usually made in volumetric flasks. You add an exact mass of a known salt or an exact volume of a specific liquid, and you add the water to make your standard solution. By getting exact volumes of acids or bases in the solution, you can make a standard solution. In other words, I know what's happening in there. You would always read the bottom of the meniscus, and you don't have an error of parallax. You need to bring your eye into the level so that it can see the meniscus straight. What happens inside solutions? Generally, we're going to dissolve salts into water, and salts, you all know by now, I hope, are ionic substances, and that means there's some or other positive ion and some or other negative ion. So let's take sodium chloride, and the water molecules will orientate themselves with the slightly positive H hydrogen atoms of the water closer to the negative ions, and the slightly negative oxygens closer to the positive sodiums. So when they break up into their ions, we call that dissociation. So if, for example, it was NaCl, and I put that into a water solution, it will dissociate into Na plus and Cl minus. What are the forces inside here? Well, we've got a whole lot of different forces. One is we have what is known as an ion dipole intermolecular force. We have, if these two were next to each other, there would be an ionic bond. And if the two waters are attracted to each other, that is a hydrogen bond. So those are all inside the solution. Ion dipole intermolecular forces exist between the ions and the polar covalent water molecules. Remember that a milliliter is a centimeter cubed and a liter is a decimeter cubed. So if I'm going to convert, 1 liter is equal to 1,000 milliliters, and by the same token, 1 decimeter cubed is equal to 1,000 centimeters cubed. So, show the balanced chemical equation to show the dissolution of sodium chloride in water. Now, sodium chloride, we've just discussed that right now, is an ionic substance. It is going to unassociate. This is a solid. When I put it into water, it becomes aqueous, and it is positively charged, plus the chloride ion, which is also aqueous. Show a balanced equation to show the dissolution of silver nitrate. Well, first we need to know what silver nitrate is. It's AgNO3. Remember that silver has got a valency of 1, nitrate has got a valency of 1, and therefore it's going to be silver nitrate. I pop that into water, and this is again a solid, and I get the Ag plus ion in aqueous form and the nitrate minus ion in aqueous form. So that is dissociation, and sometimes when we're doing a dissociation in a solution, we call it a dissolution. Okay, periodic table, handy little thing if we're going to start doing some calculations. So if I've got 29.5 grams of sodium chloride and I dissolve it in 250 milliliters of water, Name the solvent. The solvent is the water. The solute is the sodium chloride. And what is the concentration? Concentration is equal to number of moles divided by volume. Before I can work out the number of moles, I'm going to have to say number of moles is mass over molar mass. So 29,25 over the molar mass of 23 plus 35,5. So we land up with 58,5. And that turns out to be 0,5 moles of sodium chloride. 0,5 divided by, I need it in decimeters cubed, so 250 milliliters is centimeters cubed, which is equal to 0,25 decimeters cubed. So 0,25 goes in there, and I land up with 2 moles per cubic decimeter.